When selecting a circuit tracer, several factors contribute to its effectiveness and suitability for different tasks. These factors include sensitivity, accuracy, versatility, and ease of use. Considering these aspects will aid in choosing a tracer that aligns with specific needs and budget. The Klein Tools ET610 circuit tracer stands out as a well-rounded option, offering a high sensitivity pro for detecting circuits even in noisy environments. Its non-contact voltage detection enhances safety, while adjustable sensitivity helps filter out unwanted signals. Clear light-emitting diode indicators and audible tones facilitate quick identification. However, it may not detect circuits with very high or low currents, and it requires a 9V battery, which is not included. The Fluke 902FC True RMS clamp meter with iFlex offers true RMS measurements, ensuring accurate readings on non-sinusoidal waveforms. The iFlex flexible current probe enables measuring large conductors. It also incorporates a built-in circuit breaker finder and Bluetooth connectivity for app integration, along with a rugged and durable design. Nevertheless, it is more expensive than dedicated circuit tracers and may not be as user-friendly for basic circuit tracing. The ideal Industries SureTest 100 circuit tracer kit provides a compact and affordable solution with both a transmitter and receiver. It features clear visual and audible indicators and can detect circuits even through walls and ceilings. A ground fault circuit interrupter outlet tester is included. However, it is less sensitive than some higher-end tracers and may struggle with long or complex circuits. The Amprobe CCP-550 circuit breaker finder is specifically designed for tracing circuits in electrical panels. It is fast and easy to use, indicating the location of a circuit breaker with light-emitting diode lights. It can detect circuits even when the breaker is turned off. However, its utility is limited to tracing circuits in electrical panels and may not be as versatile as a general-purpose circuit tracer. When considering the best overall choice for accuracy, sensitivity, and value, the Klein Tools ET610 is a strong contender. For advanced features and versatility, the Fluke 902FC is recommended. The ideal Industries SureTest 100 offers the best budget-friendly option for basic circuit tracing. Lastly, the Amprobe CCP-550 excels at specifically tracing circuits in electrical panels. Circuit tracers utilize the transmitter and a receiver to identify the path of a specific circuit. The transmitter injects a signal into the circuit, which the receiver then detects and traces. Understanding how these devices work can help optimize their use and troubleshoot any issues that may arise. The transmitter typically connects to the circuit through an outlet, a bare wire, or a circuit breaker. Once connected, it sends a unique signal that travels along the wire. The receiver, which is usually a handheld device, is then used to detect the signal. By following the signal strength, you can trace the path of the circuit. Sensitivity adjustments are crucial for accurate tracing. In noisy electrical environments, reducing the sensitivity can help eliminate false positives from adjacent wires or other sources of electromagnetic interference. Conversely, increasing the sensitivity may be necessary when tracing circuits through walls or in areas with weak signals. Some circuit tracers also feature filters that can block out specific frequencies of interference, further improving accuracy. When tracing circuits, it's essential to follow safety precautions. Always to energize the circuit before connecting the transmitter, and use non-contact voltage detection to ensure that wires are not live. Wear appropriate personal protective equipment, such as gloves and eye protection. Be aware of potential hazards such as exposed wires, damaged insulation, and improper grounding. Circuit tracers can be invaluable for a variety of electrical tasks, including identifying breakers, tracing wires and walls, and troubleshooting faults. They can save time and effort compared to traditional methods such as trial and error or visual inspection. To ensure the longevity and accuracy of your circuit tracer, proper maintenance and storage are essential. Keep the device clean and dry and store it in a protective case when not in use. Regularly check the battery and replace it as needed. If the device becomes damaged or malfunctions, have it repaired by a qualified technician. When using a circuit tracer, it is helpful to understand the basics of electrical circuits. A circuit is a complete path that allows electrical current to flow from a source, such as a power outlet or generator, through a load, such as a light bulb or appliance, and back to the source. Circuits typically consist of wires, switches, fuses or circuit breakers, and various electrical components. There are two main types of circuits: series and parallel. In a series circuit, components are connected end to end, so the current flows through each component in turn. If one component fails, the entire circuit is broken. In a parallel circuit, components are connected side by side, so the current has multiple paths to flow through. If one component fails, the other components continue to function. Circuit breakers and fuses are safety devices that protect circuits from overloads and short circuits. An overload occurs when too much current flows through a circuit, which can cause wires to overheat and potentially start a fire. A short circuit occurs when a wire accidentally comes into contact with another wire or a grounded surface, creating a low resistance path for the current to flow. Circuit breakers and fuses are designed to trip or blow when the current exceeds a certain level, interrupting the circuit and preventing damage. Understanding the layout of electrical panels is also crucial for effective circuit tracing. Electrical panels, also known as breaker boxes, are typically located in a central area of a building and serve as the distribution point for electrical power. Each circuit in the building is connected to a circuit breaker in the panel. Circuit breakers are labeled to indicate which circuits they control. However, these labels may not always be accurate, which is where a circuit tracer comes in handy. When tracing circuits in an electrical panel, start by identifying the breaker that you suspect controls the circuit you want to trace. Turn off the breaker and then use a non-contact voltage tester to confirm that the circuit is de-energized. Connect the transmitter of the circuit tracer to the circuit, either through an outlet or directly to the wire. Turn on the transmitter and then use the receiver to scan the breakers in the panel. The receiver will indicate which breaker is connected to the circuit. The process of tracing circuits can sometimes be challenging, especially in older buildings with complex wiring systems. Here are some tips for troubleshooting common issues. If you are unable to detect a signal with the receiver, check the battery in both the transmitter and receiver. Make sure the transmitter is properly connected to the circuit and that the circuit is de-energized. Adjust the sensitivity of the receiver to ensure that it is not too low or too high. If you are getting false positives, try reducing the sensitivity of the receiver or using a filter to block out interference. If you are tracing circuits through walls, try using a higher sensitivity receiver or a specialized wall tracing probe. If you are tracing circuits in a metal conduit, be aware that the conduit can shield the signal and make it difficult to detect. In this case, you may need to use a specialized conduit tracer or remove sections of the conduit to expose the wires. Circuit tracers have evolved significantly over the years, with newer models offering more advanced features and improved performance. Some modern circuit tracers include features such as wireless connectivity, data logging, and smartphone integration. Wireless connectivity allows you to transmit data from the circuit tracer to a computer or mobile device for analysis and reporting. Data logging allows you to record measurements over time, which can be useful for troubleshooting intermittent problems. Smartphone integration allows you to control the circuit tracer from your smartphone or tablet and to view measurements and data on a larger screen. Circuit tracers are essential tools for electricians, but they can also be useful for homeowners and do-it-yourselfers. If you are comfortable working with electricity, a circuit tracer can help you safely and easily identify and trace circuits in your home. However, it is important to follow safety precautions and to consult a qualified electrician if you are unsure about any aspect of the process. Choosing the right circuit tracer depends on your specific needs and budget. Consider the factors discussed above, such as sensitivity, accuracy, versatility, and ease of use, and read reviews from other users before making a purchase. With the right circuit tracer, you can save time, effort, and frustration when working with electrical circuits. Proper use of a circuit tracer involves several key steps to ensure accurate and safe circuit identification. Firstly, always begin by de-energizing the circuit you intend to trace. This involves turning off the corresponding circuit breaker or removing the fuse that supplies power to the circuit. Confirm that the circuit is indeed energized by using a non-contact voltage tester or a multimeter to check for any voltage present in the wires or outlets. Secondly, once the circuit is energized, connect the transmitter of the circuit tracer to the circuit. The method of connection will depend on the type of circuit and the available access points. For outlets, you can plug the transmitter directly into the outlet. For bare wires, use alligator clips or other suitable connectors to attach the transmitter to the wires. In electrical panels, connect the transmitter to the circuit breaker or to the wires connected to the breaker. Thirdly, after connecting the transmitter, turn it on. The transmitter will inject a unique signal into the circuit, which the receiver will detect. Some transmitters have adjustable signal strength settings. Start with a low signal strength and gradually increase it as needed to achieve a clear signal. Fourthly, use the receiver to trace the circuit. Hold the receiver near the wires, outlets, or circuit breakers and listen for the audible tone or watch for the visual indicator that signals the presence of the transmitter's signal. The receiver will typically have an adjustable sensitivity setting, allowing you to fine-tune its ability to detect the signal. Adjust the sensitivity as needed to eliminate false positives and accurately pinpoint the circuit's path. Fifthly, follow the signal along the circuit's path. As you move the receiver, the signal strength will increase as you get closer to the circuit and decrease as you move away. Use this information to trace the circuit through walls, ceilings, and electrical panels. Be patient and methodical, and take your time to carefully follow the signal's path. Sixthly, when you reach the end of the circuit, verify that you have indeed traced the correct circuit. For outlets, plug a test device, such as a lamp or a multimeter, into the outlet and confirm that it is powered by the circuit you traced. For electrical panels, check the wiring diagram or use a multimeter to verify that the circuit breaker you identified is connected to the circuit you traced. Some common mistakes to avoid when using a circuit tracer include failing to de-energize the circuit before connecting the transmitter. This can result in electric shock or damage to the circuit tracer. Incorrectly connecting the transmitter to the circuit can lead to inaccurate tracing results. Make sure the transmitter is securely connected to the wires or outlets and that the polarity is correct. Using excessive signal strength can cause the signal to bleed into adjacent circuits, making it difficult to accurately trace the desired circuit. Start with a low signal strength and gradually increase it as needed. Moving the receiver too quickly can cause you to miss the signal or to mistake the signal from an adjacent circuit. Move the receiver slowly and deliberately, and pay close attention to the signal strength. Ignoring the safety precautions can put you at risk of electric shock or other hazards. Always wear appropriate personal protective equipment, such as gloves and eye protection, and be aware of potential hazards such as exposed wires, damaged insulation, and improper grounding. Circuit tracers are designed to work on a variety of different types of circuits. However, there are some circuits that may be more challenging to trace than others. These include long circuits, circuits with multiple branches, and circuits that are buried underground or concealed within walls. When tracing long circuits, the signal strength may weaken over distance, making it difficult to detect the signal at the end of the circuit. In this case, you may need to increase the signal strength of the transmitter or use a receiver with a higher sensitivity. When tracing circuits with multiple branches, the signal may split and travel down multiple paths. This can make it difficult to determine which branch is the correct one. In this case, you may need to use a process of elimination to trace each branch individually. When tracing circuits that are buried underground or concealed within walls, the signal may be attenuated by the surrounding materials. This can make it difficult to detect the signal, especially if the circuit is located deep underground or behind thick walls. In this case, you may need to use a specialized underground tracer or a wall tracing probe.